Okay. So welcome to today's class, and today we are going to discuss about Java 8 features. Okay. After this class, we will have Java coding problems. Okay. So after that, after coding problems, we will start advanced like Spring Boot microservices. So before and also coding problems, we will see using Java 8 in a normal way. So in both ways, we will cover all Java coding problems with respect to interview perspective. Okay. So today we are going to discuss about Java 8 features. Okay. So in Java 8, for each was one of the feature was added. So previously we have a normal for each method. It will be loop. Now it will be for each directly. We can see how the for each is implemented or enhanced from the Java 8. The main is lambda expressions. Okay, the main features are here: the lambda expressions and method references and functional interfaces. Okay, so lambda expressions and the functional interfaces and the stream APIs and string joiner class with example also we will see that, and default methods and static methods in interfaces we will see, and optional classes. Optional classes, what are the optional classes, why we need optional classes? Okay, and also we have some more API also. See, you can see lambda expression, functional interface, method reference, and the default methods, and stream API, date API, and optional. So these are the main features. Okay, these are the main features. Okay, so now you can see one by one we will see all the examples here in detail. Before that, we can refer what exactly it is in a simple word. So lambda expression. So lambda expression is a function that can be shared or referred as an object. Okay. So using lambda expression, we can retrieve the data, or we can print the data, or we can share the data, and by taking a reference of an object. Okay, by taking a reference of a class or function interface. So like that, we can use this lambda expression. And functional interfaces. Functional interfaces are the interfaces which will have only one abstract method or single abstract method. The interfaces are additionally recognized as single abstract method interfaces. Okay, so recently or Java 8 is added functional interfaces which will have only single abstract method. And method references. What is the method references? So method references are the references used to function as a parameter to request a method. So whenever we are calling a method without creating an object, we can use the method references to call that function or to call that method. So how we will call, we will see, okay, in the examples. And default methods, that is what I discussed, right? Default methods. So default methods is a method provides the implementation of a method within the interface following the interface development facilities. Okay. So actually, why we need default methods? So in interfaces, like see, if you have an interface, previously we have an interfaces 100% abstract methods. Okay. So if you had the default method means some implementation within that method, right? Or if you add that normal abstract method, you need to implement all the implemented classes. So to avoid that situation and to give that backward compatibility, the default methods are came into the picture inside that interfaces. So whichever you want to implement the classes, you can take that override that default method, or you can take that same uh, whatever the default implementation, you can take that. So for that backward compatibility, we have the default methods in an interface. And the stream API. So stream is nothing but a collection of a data, some amount of data. API means application programming interface, which will provide some API methods, so that we can use these methods by applying stream on some collections. So you can see Java Stream API is a abstract layer, implements pipeline processing of data. It is a pipeline processing of data, which means if you have a collection data collection, you need to filter. If you want to filter the data, if you want to manipulate the data based on some criteria, based on some conditions, you can use Stream API methods or Stream APIs. Okay. And datetime API. So previously we have before Java 8 we have date and time, and also Java 8 also we have date and time. So what is the difference between them? So before Java 8, Java 7 up to Java 7, the date API was not thread shaped, and also from the Java 8 it is a thread shaped. So that is the difference they introduced in Java 8. And optional. So optional is one of the class. So for example, if you are getting a result or records from the database, if the records are empty or records are null, you will get a null point exception whenever you are getting some getting that data from the database. So in that case, instead of returning a null, you can you can take that information into the optional class, and it will you can return a empty kind of thing if else condition is there in optional class. Based on that, you can return an empty instead of a null or null point exception. So using optional class, we can avoid the null point exceptions, or and we can send the default implementation when the collection or data is empty or null. Okay, so these are the features. So are you clear? We will go one by one. Okay, if you are clear.
Okay.
Yes.
Yes.
Okay. So now starting on with lambda expression. What is lambda expression? Lambda expression is an anonymous function which have a set of parameters, lambda like arrow mark, and the function body. You can call the function without name. Okay. Previously, it is an anonymous function. Previously, we have a inner classes. To replace inner classes, the lambda expressions that came into the picture. So whenever you want to call any function, you don't need to create an object for that class. Directly, you can use this function to call those methods by using that by applying that lambda expressions. How we can call, we will see. Lambda expression is newly important feature which is in a Java 8, included in Java 8. It provides clear and concise way to represent a method interfacing using an expression. So by using an expression, we can see that a very clear field. It is very useful in collection library. So whenever you are handling the data in a collection, it is very useful. Okay, it helps to iterate, filter, and extract data from collection. Okay, it will do this many kind of operations, which means we can use the lambda expressions in a stream APIs. We can use the lambda expressions to iterate the collection. We can use the lambda expressions using stream API like filter and extract methods. Okay, iterate methods. We can see the lambda expressions using provide the implementation of the interface, which is a functional interface, and this is one part. So lambda expressions also, which is providing an implementation for the functional interfaces. So it saves the lot of code. In case of lambda expressions, we don't need to define a method again for providing an implementation. Okay. For example, if you want to call a method from the super class, it is a super interface. You need to write a method and you need to override that method at that, right? So you don't need to call like that. You don't need to do such type of activities. Directly, you can call that method using lambda expressions. So, and also lambda expressions is a treated as a function. Is a treated as a function, so that compiler will not create the dot class file for this. Okay, we will see why use lambda expressions. Okay, what is lambda expressions? We learned. So now why we used? So to provide implementation of functional interface, and also we can take the less coding when we are raising an lambda expression. And also I can see that example. Okay, with the lambda expression with the example I will show you. Okay, so in this class only I will show you. Below I added. Okay, and method references. Method references are used to refer the method functional interface. It is nothing but a compact way of a lambda expressions. So compact way of a lambda expression is nothing but a method references. We will see. Okay, you can simply replace the lambda expressions with the method references if it is a static method. Like see, syntax, the class name, and double colons. Okay, double colons. It is a double colon 2 times, and method name. So class name dot method name we are calling, right? The same way class double colon and double colon and method name we can call. This is the syntax of method references. And now optional. So just now we discussed it, right? It wrappers the around the object. It can use the avoid the null pointer exception. So these points already we discussed. Okay. So this is an optional. So these all are questions. Okay, these all are questions related covering all the features. Okay, what is the difference between permission space and meta space? So this is also one of the Java 8 feature. So JDK 8 onwards, permission space is removed. Permission space is removed. Earlier, permission space is used to storing metadata. Metadata means storing the information about like classes, bytecode, names, and JIT information, JIT compiler information. Java classes metadata now stored in a native help. This space is called metaspace. Okay, native space, metaspace. Metaspace grows automatically by default and it will be garbage collected. Okay, so now you can see the difference between the permission space and metaspace. So if it is 32-bit JVM, we have a 64 MB, but here it is the unlimited. So we can avoid memory leak or memory kind of errors by using this metaspace. So that is the reason it the default permission space was replaced by the metaspace. Okay, memory. So here is the different sizes are there when we are using a JVM with respect to server, right? 64-bit or 34-bit, but it is allocated the unlimited, which means it will take the maximum space from the that server or a system. Okay, so you can see here. So here the heap space is there, and the permission space previously is there. It was replaced by the meta space. Okay, now we will see the what are the functional interfaces now. So functional interfaces. Okay, what are the functional interfaces? Functional interfaces are the single abstract method, and also example of the some functional interfaces. We have some predicate. Function is the functional interface. Predicate is the predicate interface, and consumer and by consumer. We have some functional interfaces. Then what is the predicate and function? Here the two different functional interfaces. Then what is the difference between predicate and function interface? Okay, both are the functional interfaces. So predicate is a single argument function and either returns true or false. So it is a kind of a single argument function. Okay. So predicate is the best replace for the if else condition. So whenever you are having a if else condition repeatedly on the same kind of dynamic objects or dynamic function, you can replace that if else by predicate functional interfaces, so that it will give you the clear picture on what you are doing, and the readability of that program will be increased, and the way of writing in a functional interfaces it will be easy. So predicate will be replaced by if else condition. This can be used the assignment, the argument, the lambda expressions or method reference. So whenever you are using a predicate functional interface, of course, if you want to write in a program, you need to use either lambda expressions or method references. Okay, lambda expressions are the expressions which will provide the implementation for these functional interfaces. Okay, functional interfaces. And the method references are a simple compact or compact way of defining a method reference. Lambda expressions is nothing but method references, right? So our method references or lambda expressions using, we can provide the implementation for this functional, the predicate functional interface. Okay, what is the function? Function is also one type of a single argument functional interface, an object to denotes the input and function, and R denotes the type of an object. So it will return an object. So here functional interface will return the true or false Boolean value, and the function interface, function is an interface, it will return the object. Okay, whenever we are implementing this. So this can be used the argument target lambda expressions or method references. So whenever we can implement a functional interface, we can use the lambda expressions or method references. Okay, that's fine. So date and time also we discussed it, right? Date and time also we discussed. So thread safety, performance, and more readable. So you can issue with the old date API in the previous one. So thread safety, you might already aware the util date is the mutable. Util date is the mutable and it is not a thread safe. Okay, it is a mutable. So repeatedly it is changing that behavior of that class. So even syntax is simple format is also not thread safe. New Java 8 date and API are the thread safe. Okay, thread safe. And performance. Java 8 new APIs are better in performance than old Java API. Okay. So more readable. Java API such calendar and date are poorly designed previously. Okay, in hard to understand. In Java 8, date and time are easy to understand and complete with iOS standards. So it is having some iOS standards, and also it will be readability of that function. This data API was is good, and implementation also is good. So that we can use. So now up to here, are you clear? We will see the example one by one. Okay, after this theory. Hello.
Yes.
Yeah,
Okay.
it's clear.
Okay, fine. So now what is the difference between collection API and stream API? So just before we discuss it, right? Collection API is nothing but it will follow some data structures, and it will have uh, it is sorry, collection APIs are created early binding, or whenever we are using the data we want to store, right? You need to create a collection object, and you need to store that data in the collection APIs, and the collections are internally for implemented using data structures. But stream API is not a data. It will not follow any data structure. It is a it will be objects are created lazily whenever we are manipulating the data dynamically, and also it is a processing data. It will not store data. Okay. So by applying some APIs are nothing but a stream filters and some methods. Okay, it will it will filter the data. It will filter the data, or it will manipulate the data based on the APIs we used from the stream. Okay, and it will give the final result. Whatever the required criteria, we can get the final result on the collection uh, data. So iterate the consumes elements the any number of times the collection object, while iterating the consumes the elements only one time for the stream object. Okay, so fine. So it will only one time. We can take the one time, and it will give. Okay. So what is the default methods and when to use it? So default methods we already discussed. It is a backward compatibility purpose. So whenever you want to add some methods in your interfaces, you can add the default methods, and you can directly use the in your implementation classes. So that is what here mentioned. Now, what is the difference between iterator and split iterator? So in Java 8, iterator is the universal iterator, and split iterator is from the Java 8. Okay. The iterator was introduced to Java 1.2, while split iterator is introduced Java JDK 1.8. Split iterator. So using an API, iterator is using the collection API, while split iterator is using the stream API. So this iterator is using for the stream API, and normal iterator is using the collection API. And also not this iterator you can use the stream API also. Why? Because this is a universal iterator. Okay, universal iterator. So universal iterator is a universal iterator, while split iterator is not a universal iterator. Why? Because split iterator you can use only streams while using streams only, but this iterator you can use anywhere in Java classes. Okay, when we are having a collection of data, whether it is a Java 8 features or it is a normal Java collections, you can use anywhere. This is what in predicated function we already discussed this one. Now Java 8 internal and external iteration. So okay, iteration we already did. So internal is nothing but for each, and external is nothing but also for each. We will see those how we are defining. So external iterators means the loops, for loops. We can say it as a for loops. So this iterator is also known as a active iterator or a explicit iterator. This is a external iterator. Before Java 8, how we are traversing the data, we will see. Iterator means iterating the data one by one, control over the iteration. So for this type of iteration, control over the iteration of the elements within the programmer, which means the programmer define the when the next element iteration is called, which means we are defining this one of the for loop we are defining, and we are taking item one by one. We are taking item one by one. If you want to stop using for loop also, it is enhanced for loop. Using for loop also, if you want to stop some I is equal to 1 or I is equal to 2, I is equal to 3, so it will have the over the controller in a Java developer. This is a external iteration, which means this one using for each loop. Okay. Now you can see the traditional iterating elements using the external iterator. This is also one type of iterator. So here it is the list we are seeing. Here it is the map. So map will give the entry So these are the map. We have all the entries here. String comma string. One and we are adding elements here. The for each. So map dot entry string comma string. This is the map object and entry. So entry set map dot entry set will give the all the key value pairs. So entry dot get key and entry dot get value. We will get the values here. So this is also one type of actional iteration. Okay, actional iteration. This is actional iteration. Iteration means how we are traversing, how we are taking the elements from the collection. This is what we can call it iteration. Then what is the internal iteration? We will see. So internal iterators. This iterator is also known as a passive iterator, implicit iterator, or callback iterator. For this type of iteration, the controller over the iteration elements lies with the iterator itself. Okay, lies with the iterator itself. It is not over the control of the developer. So completely control will be the iterator itself only. The programmer can only tells the iterator. The programmer only tells the iterator what operations is to be performed on the elements of the collection. So like a filter, like a sorting mechanism, or any kind of stream APIs we can use while iterating that element. Other than that, we cannot control that elements. The programmer only declares what to be done and does not manage the control how the iteration will be individual elements to take place. So we don't know how the control will be happens in individual elements when we are operating having this kind of methods internally. Okay, we will see. So now you can see lambda expressions here. So we have a items is a collection. So for each iterator, which is the internal iterator. So you can see for each method, just now we discussed, right? For each method from the Java 8. So list dot for each, you can print in a normal way, or you can take this item in the sense you can take any element slash or arrow mark system dot out dot println this item. So this item that for each it will for each one by one element. What type of element? This is the element. This element only we are printing here. So like that we can use the for each method, and this for each method is also called an internal iterator, which means in Java 8. Okay. Hello. Okay. So now using map also using internal iterator. Map dot for each. No need to call map dot entry set and all. It is simply key value. So automatically internally it will convert, take the values and it will put the key and values. So now you can directly print the key. You can directly print the value. But previously how we are iterating this map, you need to give the map dot entry and you need to get that entry map dot entry set. Set will give the key value pairs and entry dot get key and entry dot get value. So like that you need to print. So like this you need to do this for method, for loop method. But for each method, simply it is a single line. Okay, you are taking key and value here. So this is what internal and external iterators in Java 8. Now you can see an example using by using all the methods from the Java 8. Okay, streams. If you want to find the distinct elements from a collection, okay, collection. For example, you are having a list here, array. So as a list, we can convert to the direct to the collection string here. So here you have A, B, C, D, A, B, C. So here we have a duplicate A and B. Okay. If you want to get the unique elements from the collection, you can apply directly stream. So it will give the list of strings. So distinct elements, list dot. This is the list dot. This is the source of your collection. So stream distinct collect. So let me share my screen. Let me show that example. So you can see here. So for each system dot out the names we are printing here, and for each of println, this is the method references. Okay, this is the method references. Using method references also, we can directly print. So this is the system dot out println, right? The same you can use the method references. The same you can use the for each. So let me run this one and let me copy the next one, next example. Both are giving same. This is using the method references, and this is using the for each loop. This is using the for each loop. Now we will take that take this example. We will take this example. Okay, take this example. Okay. So now you can see here. So let me remove this. Let me write. Okay. So list, right? So this is the list. Okay. This is the list. So list dot stream dot stream dot. So distinct elements, right? Distinct is a method. And once it is a distinct, right? Once it is distinct, you need to collect and collectors dot collectors dot to list is there, to list. So we are listing. So list dot stream is the one method, which means we are applying stream. Distinct is the one method within the stream API. So you can see here that there are number of methods are there. All, match, find, filter, any, equals, and distinct, and count, right? Distinct is also one method. So stream of strings, so or list of strings, right? It will give. So these are all methods. Okay, sorted is method is there, sorted. So if you want to do the sorting mechanism, you can use it. So these many methods are there in a stream. So one of the method I am taking the distinct and dot collect. This is also terminator to finish the collection operation. So collect and collect is dot do to list. We will see terminators also. Internal terminator. This is the internal terminator. Distinct is the internal terminator. Internal means within the collection it is terminating. Within the collection it is doing that. And external terminator means it is finishing the collection operation, right? So this is what internal terminator and external terminator of a stream. Okay. Now you can print this one. You can print. See. So we are getting only 4 variables, okay, because of this distinct method. So now you can use for each also. You can use for each also. And using for each you can pass the parameters. Okay, pass the parameters. So let me take this example. Okay, so here you are using distant elements. You are taking a distant element and you are printing a for each. Using the for each method, you are traversing all the elements and you are printing. Instead of array, you can print the one by one. See, you are taking that values. Okay, so only single one is coming, even though it is having, right? Single 2 is coming, 3 is coming, 4 is coming, only 5 is coming. So you are getting the distinct values. Okay, using distinct method and using for each also, we can directly print the using method references instead of elements. Lambda expressions. You can pass lambda expressions also. E hyphen or arrow. Okay. SYSOUT system.out.println E. You can print like this also. You can print like this also. Just simply the element you are iterating and you are printing. You can see here. See. So you can use the method references or the lambda expressions. Element. You can take any kind of character here. Element. I am taking as an element. Each one is an element. Of course, it is a distincted. So it is filtered as a distinct. Fine. And also you can instead of distinct, and also you can apply one more filter e slash, right, e greater than 2. So greater than 2. So you are taking, even though it is a distant elements, I want to take all the elements which are greater than 2. Let me write. See here, you are not getting a 2 value, 2 and 1. Previously we are getting 1, 2, 3, 4, 5. Now whenever you are applying a filter, distant is the one thing and filter is the this one. Okay, so like that you will get operations. So if you remove the here this one distant, if you remove, you can apply the filter. So greater than 2, we will have a double 3, double single 4 and double 5. You will get the duplicate values also. You can see here. So it is a simple kind of manipulation, data manipulation using these methods, But you need to know how we can apply these filters on our collection data. Okay. So this is what a stream API and this is what a stream method. So are you clear?
Yes.
Okay. So later we can check that distinct values also we can print distinct strings also. It is a distinct elements. Here at the distinct strings also you can get, right? So and also the count, distinct elements count. Distinct elements are, this is the one distinct element and this is one distinct element and this is one distinct element and this is one distinct element. So distinct elements are 4 is there. By using count also we can get. So stream API all next filter is already done and collect is already done, for each is already done, reduce is the remaining and map is remaining, right? So you can see here, all these examples. So let me copy this. Okay, let me copy this and print here remaining all operations. Okay. So you can see here, just now I am taking that 1 2 3 4 5 as a list. Okay. So now I'm printing the using list integer only, stream dot map using map function. So take an element, you can apply the you can apply the uh, you can apply the logic here. So square of, just I'm adding a square. Okay. Map function, I'm squaring each and every element. So each and every element I'm squaring from the stream. So 2 3 4 5, 2 square, 3 square, 4 square, 5 square. So element into element, right? It will give you the square operation. Once the square operation is done, you can collect, the data. Collectors dot to list, again you are taking as a list, right? You are printing that values. Fine. Now you can take the string names. Okay, reflection, collection and stream. So demonstrate the filter method. So you can see s dot starts with s dot greater than, if it is numbers greater than, you can apply any kind of operation here. Starts with s, I want to check, so only one will become. Okay. So string, list of strings will become only one. So let me add one more list we are taking, it, otherwise it will come only one. Hmm. So this is also start with s and this is also start with s. Okay. Fine. Now you can take that names. These are the names, right? Sorted, collects the to list. So we are applied the sorted method. So it will come that sorting mechanism. Based on the sorting mechanism, it will come. And I'm taking one more list. Map and collect. So this is also map, square root of map. Okay. And this is also using the lambda expressions, square root of map, like for each as well lambda expressions. And filter also using reduce method, filter and reducing 0 to answer and I, answer plus I, we are taking here. So reducing the, based on this condition we are reducing the result. Okay. So we will see here all the functions here. You can see one is the square root. So first one is the square root, right? Square, 2 square 4, 3 square 9, 4 square 16, 5 square 25. So we are getting the answer. And the second one, start with s. We have only two names only. We have only two names. So you are getting these two names, right? And the third one is the collector. So names dot stream dot sorting mechanism. C will be the first and R will be the second, and S T R E A M. So EAM 1 2 3 is the second, and this is the first. Okay, like this it is sorted. And also from here also we are sort stream dot map and collect dot to set, which means which means the unique squares are coming. Unique squares are coming, and also set will not follow the insertion order. So that is the reason we are getting the shuffling order. Okay, and also set will not load the duplicates. If you are passing a list, okay, if you are passing a list, it will give the all the duplicates values also. List. So of course we are taking as a set, right? So you need to pass a list here. Okay. Now you can see 4, 4, 9, 16, 25. So here the two toots are having, right? 4 are also coming here. So like that we are for eaching, and we are printing the values also here. So this is also we are reducing the stream filter. Let me see. This is what we are having here. Even numbers. Okay. Reduce method. Using the reduce method, we are getting even numbers. Let me copy this. After square root. See, only 6 is the even numbers in the square. Okay, 6 is the even number. Okay, numbers from these numbers, the square is the 6 is the even numbers. Numbers. It is already taken filtered, right? After filtering, it is taking the 6. So like that we can have apply the all the stream APIs within the filters. Within the stream API, all we can use the all the methods sorted or filter or map or any distinct or any kind of API methods we can use while traversing the collection, while iterating the collection, while applying the stream API on that collection iteration. So are you clear?
Yes.
Yes. Yes, sir.
Yes.
Okay. So we will have maybe tomorrow. Let me stop the recording. Okay.